Hello everybody, this is section 1.1, which is going to be statistical and critical thinking. There's going to be a lot of definitions, so if you need to pause the recording to copy them down, go ahead and do that. We're going to first start with data. Data is going to be the collections of observations, and it's such as measurements, genders, or survey responses. That can be anything that you're basically going to collect. If you have a single data value, that's going to be called a datum. So what is statistics and why are you guys studying statistics? Probably because you need it for your major, but statistics is actually the science of planning studies and experiments. It's about obtaining data. It's organizing, summarizing, presenting, analyzing, and interpreting those data and then drawing conclusions based on them. With COVID going on, we see a lot of things happening with statistics right now. It does change, and it also has a lot to do how somebody interprets something, how somebody analyzes something, how they're obtaining that data, and how are they presenting it. So you don't always assume that something is true with statistics, okay? So a population is a complete collection of all measurements or data that are being considered. The collection is a complete in the sense that it includes all of the individuals to be studied. We typically will not study a whole population. They try to do that with the census, but there's still people who don't fill out the census survey. So if you're going to remember what a population is, it's like everybody in the United States, every single living person, okay? And that's what I was here talking about the census. So a census is going to be the collection of data from every member of the population. They want to try to collect as much as they can. Most of the people that do not fill out a census are ones that low income people, because it's asking personal questions and they're embarrassed about the income that they make. Also homeless people, because they really don't have an address and so they won't fill out a census. And then also illegal immigrants will not also fill out the census, okay? But they are living in our community and part of that, so that's what a census is. So a sample is a sub-collection of members selected from a population. So if we were going to say everybody at Cape Fear, that would be the population. If I was going to say a sample of that, maybe I say just the females or just first year students or people who are 5'3", that would be a sample of that sub-collection, okay? So let's look at an example that is of a problem. And it says the Gallup Corporation collected data from 1,013 adults in the United States. Results showed that 66% of the respondents worried about identity theft. Of that question, the population would consist of all 241,472,385 adults in the United States. That's what the population is. So that's here. The sample consists of the 1,013 polled. So that's going to be your sample, because of all those people in the United States, we only actually polled 1,013. So what's the objective is to use the sample data as a basis for drawing a conclusion about the whole population. So we're basically going to take this sample and we're going to draw a conclusion about everybody in the United States, and then that's what they result. So it says 66%, and it just assumes that 66% of the whole population worries about identity theft based off the sample. So things to consider about presented data. I'm hoping that with all the data that's being presented with the COVID, that you guys will look at that and analyze it and find out some more information, and just don't look at NBC News or CBS and take them for a grain of salt. So you want to look at the poll. We have to consider the sampling method used to gather the data. So how are they collecting that? The sample data must be collected in an appropriate way, such as through a process of random selection. Does the method chosen greatly influence the fidelity of the conclusion? Absolutely, because if it didn't, so if we were going to say that we wanted to take a sample to see if people liked baseball, and they were and we were going to sit outside and taking our sampling method was just randomly asking people to fill out a survey if they like baseball, but we're at a baseball game. So we're going to assume that they all like baseball, or the majority of them like baseball, because why would they be going to a baseball game? So that method is going to influence the validity of that conclusion that everybody likes baseball. A voluntary response or self-selected samples often have bias because those with special interests are more likely to participate. An example of that is surveys on receipts from fast food restaurants. You bought fast food restaurant, so bought from the fast food restaurant, then they're asking you for a survey, and if maybe they ask you if you like cheeseburgers or something, you know, most likely that's basically a special interest. If sample data are not collected in an appropriate way, the data may be so completely useless that no amount of statistical torturing can salvage them. Another way that we talk about sampling methods: internet polls, mail-in polls, telephone call-ins, newspaper, radio, TV announcements, which give you a specific number to call. So some conclusions that we have are: you make statements that are clear to those without an understanding of statistics and its terminologies, and we're going to avoid making statements not justified by statistical analysis. So let's try some examples. We're going to say either it is impossible, possible but very unlikely, or possible and likely, these scenarios. So the New York Giants beat the Denver Broncos in the Super Bowl by a score of 120-98. Is that impossible, possible but very unlikely, or possible and likely? So I would say, give you a second. So we're going to say it's possible, but it's very unlikely to see a score of 120-98 because that's a lot of touchdowns. Is it impossible? Absolutely not. But it probably is very unlikely. How about while driving to his home in Connecticut, David Letterman was ticketed for driving 150 miles per hour on a highway with a speed limit of 60 miles an hour. So basically, it could be possible but very unlikely, or C. And this could be something where he's maybe on the Autobahn in Europe and he has a house there. So that would we need to know a little bit of information, like where actually is he driving, and what kind of car is he driving. If he was driving my daughter's Prius, I don't think that she wouldn't even hit 150 miles in that car. So some of those things do matter. When each of 25 statistics students turns on his or her TI-84 Plus calculator, all 25 calculators operate successfully. And that one is possible and likely. I mean, you might have one, but most likely all of your calculators are going to work. Thanksgiving will fall on a Monday next year. That's going to be impossible. Thanksgiving always falls on a Thursday. All right, so here we have context and source of the data. So this data is from table 1.1-1, and it consists of measured IQ scores and measured brain volumes, and was provided by 4 researchers in the article Brain Size, Head Size, and IQ in Monozygotic Twins in the journal Neurology. Okay, so here's their IQ, and then here's what they're underneath is their brain volume. So the format of table 1.1 suggests the following goal: determine if there is a relationship between IQ scores and brain volume. So if we see IQ score here is 96 to 1005, 87 to 1035 is the IQ. So as this one is higher than that one, but it's low. But now we're getting into 1281, and it's 101. 103 is 1051, which is close to that 1035. So 1079, 1104, 1439, and then there's their IQ. So the brain volume seems to be kind of all over the place. So What is a possible hypothesis for this study? And that's what it's going to be. There's a correlation. You're going to look for a correlation of something. So we're looking for a correlation between brain size and IQ. Is the source of data concerning? The only thing that it's from a reliable source, but the only thing that we can be concerned about is that all the data, so all data, may not be included. All right, so in chapter 1, page 5 of your textbook, you guys have an ebook on MyStatLab. You are going to learn about prepare, analyze, and conclude, and here is the steps for that. So here we're going to take prepare. Under prepare, you have the context. What do the data represent? What is the goal of the study? Those are the two questions that you should ask. You're going to look at the source of the data. Are the data from a source with special interest so that there is pressure to obtain results that are favorable to the source? Is somebody going to make money off of the vaccine that comes out? So we need to be careful about what's going on. The sampling method. Were the data collected in a way that is unbiased, or were the data collected in a way that is biased, such as a procedure in which respondents volunteer to participate? So you want to look at that sampling method. After you do that, we're going to analyze it. Typically, you're going to graph the data. From that, we're going to explore that data. Are there any outliers? An outlier would be if you guys are taking a test and I'm looking at the grades to see if maybe the test was too hard or a test was too easy and somebody got a 0 because they did not attend. That's an outlier. So that's somebody who was very far away from the most other data. And that person is really going to skew the data, so we need to take them out. What important statistics summarize the data? We're going to look at different means. So mean, the standard deviation. How are the data distributed? Are there missing data? And did many selected subjects refuse to respond? Which you would have that information. And we're going to use technology. In this class, we will be using a calculator and be using some methods by hand. You're not going to do that in the real world. Most of this has technology to be able to do it for you. All right. Then you make a conclusion. Does it have statistical significance? Do the results have statistical significance, or do the results have practical significance? So let's consider what statistical significance is. Statistical significance is achieved in a study when we get a result that is very unlikely to occur by chance. So consider the likelihood of getting the results by chance. If the results could easily occur by chance, then they are not statistically significant. If the likelihood of getting the results is so small, then the results are statistically significant. So let's look at an example. One example that I have, and I will type it out for you. Would be getting 98 girls in 100 random births. That's going to be statistically significant. Because such an extreme So getting 98 girls in 100 random births is statistically significant because such an extreme outcome is not likely to result from random choice. So what does that mean? Because a girl if I was going to get pregnant, which is not possible. So you probably would have liked that joke if we were in class. It's a 50-50 chance when you decide to have a child, whether you're going to have a boy or a girl. 50-50. So if I had 100 births and 98 of them were girls, that's a 98% probability right there that you were going to have a girl. That's an extreme outcome. So getting 52 girls. Now, what about if we change this to getting 52 girls in 100 births? Now, that's not statistically significant because that event could easily occur with random chance, okay? So here's an example. In a test of the Atkins weight loss program, 40 subjects using that program had a mean weight loss of 4.6 pounds after 1 year. We know this is statistically significant, but would you try this program? Why or why not? Well, we all want to try, probably weight loss and food is all that we've been seeing on commercials all the time. So using common sense, it doesn't seem very worthwhile to pursue a weight loss program resulting in such relatively insignificant results because you had a mean weight loss of 4.6 pounds after 1 year. 1 year. But, so someone would probably not want to lose more than that. Would want to lose more than that. So this says it's statistically ineffective, but how about if you wanted to lose 46 pounds? So if that said after the year that we changed the mean weight loss for the Atkins was 46 pounds after 1 year, then that would be pretty statistically significant. So I don't think people are going to go on a weight program, and that is the actual weight loss of an Atkins program. All right, so if we look at graphs and how to graphs, thinking critically, here's a graph. And to correctly interpret a graph, you must analyze the numerical information given in the graph so as not to be misled by the graph shape. Read the labels and units on the axis. So if we have to the left here, we have California, Nevada. And then on the left hand, on the y-axis, you have the personal income per capita. If you look at the A graph, you see that there's not much of a difference. I mean, it's probably about, $2,000 between California and Nevada. Over here, however, they changed the whole graph. If you look here, they're going to start at 30,000. So their point of origin on the graph is now 30,000, which is right here. And this one is 0. And by doing that, they also increase by 1K. Here they're increasing by 10K. So here's some significant differences. So right here it shows that California, it would show, if you looked at this graph on the right hand side, you would think that California income was much more personal income per capita than Nevada's, but it's not the case. There are some bad graphs out there that you can actually find. Here's another one using a pictograph. So part B, which is over here, is designed to exaggerate the differences by increasing each dimension in proportion to the actual amounts of oil consumption. So here we have USA, and the daily oil consumption would be 20, and Japan is 5. And they put this big giant barrel here to show. So there is a pretty big difference here if you think it's because it's exaggerating. So you just need to be very careful about looking at graphs. We also have bad samples. A voluntary response sample or self-selected sample is one in which the respondents themselves decide whether to be included. The major issue is we can draw valid conclusions only about the specific of people who choose to participate. So if you are a Biden supporter, then maybe you might participate in a survey about Biden, but people that don't like Biden might not participate. Or same thing with Trump. If you're a Trump supporter, you might participate in a survey about Trump, but since you don't like him, you're not going to participate. All right, correlation and causality. Correlation does not imply causality. We cannot conclude that one variable causes the other just because there may be a statistical correlation. An example here would be the last 5 years has seen an increase in TV shows and movies about zombies. In the last 5 years, we have also seen a rise in iPhone usage. There's no way one of these caused the other, even though there may be a correlation in the two. They didn't cause. How about an example of ice cream sales is correlated with homicides in New York? So as the sales of ice cream rise and fall, so do the number of homicides. Does that mean that the consumption of ice cream causes the death of people? No, two things are correlated doesn't mean one causes another. Correlation does not apply casualty, or in our example, ice cream is not causing the death of people. However, when they start selling ice cream, people are outside, the weather is nice, and homicide rate goes up. So it's more of a correlation based on the weather. And in the winter, you've seen that crime rates actually go down. All right, let's talk about small samples. Small samples or conclusions should not be based on samples that are far too small. An example would be, the national report said that among secondary school students suspended in one region of the U.S., 67% were suspended at least 3 times. However, this was only based on 3 students that they made that. So your sample size for this was 3. Percentages, misleading or unclear percentages are sometimes used. If you take 100% of a quantity, you take all of it. If you improve by 100%, does that mean you are perfect? So you need to know how things were done before. The phrase giving 110% doesn't make sense because there's nothing more than 100. I know that that's not the case sometimes if you get extra credit. Some teachers won't go over 100%. Others, I try to give the advantage. If I was going to give an extra credit question, I would give it over. Another one example would be Continental Airlines ran ads claiming that lost baggage is an area where we've already improved 100% in the past 6 months. What is wrong with this statement? In an editorial criticizing this statement, the New York Times correctly interpreted the 100% improvement to mean that no baggage is being lost, which was not true. So their ad was actually pulled. How about loaded questions? So if survey questions are not worded carefully, the results of a study can be misleading. Survey questions can be loaded or intentionally worded to elicit a desired response. An example would be, too little money being spent on welfare. 19% said yes. The difference is too little money being spent on assistance to the poor. They changed it, just welfare to assistance to the poor, and 63% said yes. Those are loaded questions. Order of questions. Questions are unintentionally loaded by such factors as the order of items being considered. Would you say traffic contributes more or less to air pollution than industry? Here, the results said 45% blamed the traffic and 27% blamed industry. Traffic was first. Would you say industry contributes more or less to air pollution than traffic? Just by switching it, it went from 57% blamed industry, while 24% blamed traffic. A non-response occurs when someone either refuses to respond to a survey question or is unavailable. People who refuse to talk to pollsters are likely to be different than those who do not. Some may be fearful of strangers and others jealous of their privacy, but their refusal to talk will demonstrate that their view of the world around them that is markedly different than those who let poll takers into their homes. Those are non-response. Missing data. Missing data can dramatically affect results. Subjects may drop out for reasons unrelated to the study. Some examples would be unemployment data. People with low incomes are less likely to report their income. U.S. Census suffers from missing people. And this is where I went back in the beginning and I talked about the census. How about a self-interest study? Some parties with interest to promote will sponsor studies. Be wary of a survey in which the sponsor can enjoy monetary gain from the results. When assessing validity of a study, always consider whether the sponsor might influence the results. So an example of that could be in a response to Super Size Me, a McDonald's VP went on an all McDonald's diet and lost 10 pounds. So that is going to be a self-interest study. Precise numbers. Many people incorrectly assume that a precise figure is also accurate. A precise number can be an estimate and should be referred to that way. Brushing your teeth 2.54 times a day versus 2 times a day. One sounds more scientific than the other. Our current U.S. population is 305,587,865, or the current population is over 300 million. How about deliberate distortion? Some studies or surveys are distorted on purpose. The distortion can occur within the context of the data and the source of the data and the sampling method or the conclusions. All right, here's an example. In an ABC Nightline poll, 186,000 viewers said each paid 50 cents to call a 900 telephone number with their opinion about keeping the United Nations in the United States. The results showed that 67% of those who called were in favor of moving the United Nations out of the United States. What is wrong with this survey? So this is considered a self-interest, and it's a voluntary poll. Also, it costs money to vote. So only passionate people are actually going to vote. You're going to be missing people who didn't watch the nightly news. All right, the Hawaii State Senate held hearings when it was considering a law requiring that motorcyclists wear helmets. Some motorcyclists testified that they had been in crashes in which helmets would not have been helpful. What's wrong with this data? You're going to they're only talking to people, only people a lot of times only the people that disagree will speak up. People that died cannot speak for themselves. So these are people that died because they weren't wearing a helmet. So they're out of that. Also, we're probably missing data. And it doesn't affect people that wear the helmet. They're not going to respond to it. Okay, on this side, we have some math review. This is going to be to find a percentage. If you look at this, you want to remember that if it's a percent, the number in front is divided by 100. Sorry, I went off the little tablet there. So percentage, to find a percentage, you're going to take 6% of 1,200. 6 divided by 100 is putting that into a percent. That first number is going to be the percent. Times 1,200 people gives you 72 people. That's the 6% of 1,200. To convert from a fraction to a percentage, if you take 3 divided by 4, that's 0.75, and then times that by 100, which means I'm going to move the decimal to the right twice. So to go to percentage, you move the decimal to the right, and to go to decimal, you move the decimal to the left too. Okay? So decimal to percentage. To convert from a decimal to a percentage, you're going to multiply it by 100. So 0.25 times 100 is 25%. You don't have percentages in your calculator, so on your calculator you have to use the point. Always change a percent to a decimal. So percentage from percentage to a decimal. So if I have a percent, I can either move that decimal 2 places to the left, and that would do it, or divide by 100. So that's just some math review. That's going to take care of 1.1. Your next video to complete will be 1.2.